Alright. Today we're talking about a few more different power rules, and then we're going to take a look at, now that we've been talking about exponents, we're going to talk about how to recognize and how do these influence function values in graphs. So, these are the two rules we're going to talk about. The first one is called the power of a power rule. So to find the power of a power, you simply multiply the exponents. So looking at that, it says 5 squared to the 5th. That means you have 5 squared 5 times, right? Then if you add those, 2 plus 2 plus 2 plus 2 plus 2, you end up with 5 to the 10th. So we simplify that simply by going 5 to the 2nd to the 5th, gives me 5 to the 2 times 5, or 5 to the 10th. And then the power of a product means that you have two numbers inside parentheses that you're multiplying, and you have an exponent on the outside of the parentheses. But what do? We distribute the power to both things. So 5x to the third. Now this time the third goes to both of them because of the parentheses. If you don't have the parentheses, the third only goes to the x. But because of the parentheses, it's 5 to the third, x to the third. So in a video a couple of videos ago, you saw where I said like 5x cubed. The cubed simply went with the x because there was no parentheses. This time we have those parentheses, and so it distributes to both things. So let's take a look at some examples. Let's take a look at some examples of how this works. So example number 1. Again, they're just going to tell us to simplify. So the first one, we just have 9 to the 6th to the 2nd. Part B, it's going to be q to the 4th to the 5th. And then part C, it's going to be 2 cubed to the negative 2. So for our first one, we have 9 to the 6th to the 2nd. So again, we just simply multiply, because that means you have 9 to the 6th 2 times. So 9 to the 6th times 2, which simply gives us 9 to the 12th. And I won't make us figure that out. 9 to the 12th is going to be quite large. Because if you think about 9 times 9 is 81, times 9, and then we just keep going from there. So it's going to be a pretty big number. Q to the 4th to the 5th, 4 times 5, we simply get q to the 20th. Over here we have a negative exponent. Same thing, it doesn't change anything. 2 to the 3rd to the negative 2, 3 times negative 2 is 2 to the negative 6th. We never want to leave it in negative exponent form. You always want to get rid of the negative exponent. So, how do we get rid of the negative exponent? It's 1 over 2 to the 6th. And that comes from that previous video on negative exponents, that you just simply take the reciprocal and move it from the top to the bottom, and that gets rid of the negative in the exponent. Very good. So let's take a look at example 2. And again, same directions, we are going to simplify. We're going to have 3 examples here as well. But these ones are going to be on the power of a product instead. So the first one we have 5r to the 7th squared. Then we're going to have 2x to the 6th, y to the 3rd. This is all to the 4th. Okay, so we're just going to do 2 because that last one gets pretty lengthy. And then once you get that hang of it, they're all going to be pretty similar. So let's take a look at this one down here. Again, we have 5 times r to the 7th. There's a product happening, so what we want to do is we want to distribute the 2 to both of them. Well, 5, so that means it's going to make it 5 squared. Now this one already is an exponent. So that now tells me I have r to the 7th squared, which what do we do up here? We multiply. So that gives me r to the 14th. So if you want to multiply that out, because we know what 5 squared is, that would give us 25 r to the 14th. So not too bad there, just multiple rules now coming in. So now that we have all these rules, we have the multiplying monomials rule, which is when you have power times a power, you add the powers. When you divide, you subtract the powers. When you have negatives, you reciprocate it. When we have a power to a power, you multiply. And when you have the power of a product, you distribute it. So there's a lot of things that could all be happening here. So you want to pay close attention to that. So over here, this 4 gets distributed to everything. Okay, so we're going to have 2 to the 4th, then we're going to have x to the 6th to the 4th, and then y cubed to the 4th. Okay, so it gets carried out over everything. So 2 to the 4th is 16. X to the 6th to the 4th is x to the 24th, and y to the 3rd to the 4th is y to the 12th. And that's where it stops. There's no other ways to combine any of those things. That is all the further that we can take it. Alright, and I want to do one more example. Kind of a when am I ever going to see this sort of a thing example, but it's fun to do it as an application for these rules. We're going to find the volume of a cube. However, the side lengths, instead of being given to us in numbers like we would be used to, the side lengths are going to be in terms of variables. So they simply say, find the volume of the cube. So the cube we're looking at and again, since it's a cube, all the sides are the same, right? What's the volume formula for a cube? Remember, volume for a cube is length times width times height. What's my length? My length is 2xy to the 5th. What's my width? 2xy to the 5th. What's my height? 2xy to the 5th. Well, I have this thing 3 times. So can't I just write it as 2xy to the 5th cubed? I can just write it as one monomial, right? I distribute this, so that means I have 2 cubed, x cubed, and then when I distribute the cubed here, it turns into y to the 15th because I have to multiply. So the only way we can simplify now is to say 2 cubed is 8. So it's 8x cubed y to the 15th. And if you multiplied it up here, 2 times 2 times 2 is 8, x times x times x is x cubed, y to the 5th times y to the 5th times y to the 5th. Remember that you add those exponents, gets us y to the 15th. So it's the same either way. We can do it either multiplying it by that first row that we wrote, or by doing it with the exponent, with the cubed. Either way, you're going to get the same answer. So again, that's one of those, when am I going to see a cube with those dimensions? You may never in your life, depending on what you want to do, but that could be the case if you go into product design or architecture or some different things. You could see dimensions of items like that. So you just never know. Alright, and that concludes this part of the lesson on the product, the power of a power and the power of a product. But now what we're going to do is we're just going to look at some examples of how do we identify linear versus non-linear functions. Okay, so linear versus non-linear functions. And so later, the rest of this unit, we're going to look at some of those specific nonlinear functions. Like the next unit is on quadratics. The unit after that, we're going to talk about cubic and higher order functions. And again, not a lot with those, but we're going to dive into those a little bit so by the time you get to algebra, you are ready to go with some of those higher order functions, okay? So right now, we're just going to, the graphs are the easy part. So we are on example, this is example number 4 for this lesson. If I give us two graphs, and this is one of them, and this is the other one, linear versus nonlinear. So we know linear, if you look at the word, what word do we see within it? Has to be a straight line, right? Not a curve, not anything other than a straight line. So this is, obviously, this is going to be non-linear. This is a straight line, so it would be linear. So with graphs, they are as simple as that. You simply look at it and you identify, is it linear or is it non-linear? We're not going to identify what type of graph that is. You will do that when you get to Algebra 2, actually. Algebra 1 maybe, but most likely Algebra 2. Now, let's say it is not that easy. And let's say instead they give us a little bit harder. So we're on example 5 now. And let's say they gave us equations to look at. So if I have 3x plus y equals 7, or let's say they gave us y equals 2x squared. Now, we have identified, and we've already been working with some linear functions, right? Because we've worked with slope-intercept form and point-slope form, right? They were all no exponents. So if you multiply variables, or if you have an exponent on a variable, it is a non-linear. If they're just regular variables, it's linear. So this is the kind of stuff we've been dealing with before. So this would be linear. This, x has an exponent on it, so this would be nonlinear. Again, we don't know what kind of nonlinear function it is. There's all kinds of them. All we know is that it's not a straight line, so it's nonlinear. The last part you're going to look at, so again, that's also a little on the easy side, because you can just look, do I have exponents on variables? And if you do, nonlinear. The last part that we're going to look for are in tables. So let's say we have an XY table. This is where it takes a little more work to get to the answers. So we have 2, 4, 6, 8 for the x's, and for the y's we have 1, 2, 3, 4. And then let's say for the other one we have an x and a y chart with 1, 2, 3, 4 for the x's. And then we have 1, 4, 9, 16 for the y's. Now we've looked at these with proportional versus non-proportional, right? We're increasing by 2's on this side. We're increasing by 1's on this side, right? Proportional. If it's proportional, it's linear. So if they're increasing by the same amount each time, it's linear. Over here, increasing by 1's, by 3, by 5, by 7. Non-proportional, non-linear. Okay? Because it's increasing by different amounts each time, which means that it is not linear. Okay? It's not going to give us that straight line function. So that is all the further I want to take that section. So that's just kind of a glimpse of nonlinear versus linear. In the rest of this chapter, we'll take a look at some of those nonlinear functions. We'll take a look at something called quadratics. We'll take a look at something called cubics. And then we'll also take a look at some higher order exponential functions. Okay, so we'll take a look at some of those things over the next few videos. So stay tuned for that.